Okay, we're going to go ahead and get started. Hello and welcome everyone. We're excited that you're joining us today. It's always exciting to get a good crowd on a pressing and relevant topic. We're doing a sample lecture today for the Schar School of Policy and Government within our biodefense program, led by Associate Professor Greg Koblenz, who leads our graduate certificate, our master's, and our PhD in biodefense. Just a couple of quick housekeeping things. Now, our approach with events like this, one of the main reasons we do these events is we want to give you all an opportunity to listen to not just, what we talk about, but how we talk about it, how faculty engage with students on the material. Professor Koblenz is going to go through this specific topic over a series of slides. He'll come towards the end. There will be a Q&A at the end. Please use your Q&A function on Zoom for questions you may have. Rather than the chat, please use Q&A for that. And Professor Koblenz will certainly let you guys know when we're ready to field questions. And with that, it is my pleasure to hand it over to Professor Koblenz.
Great. Thanks, Travis. Welcome to everyone who is viewing this sample lecture on whether the COVID-19 pandemic will inspire additional states and non-state actors to acquire and use biological weapons. This lecture actually draws on two topics that I teach about in different classes as part of the biodefense program. One class on biodefense strategy and one class on terrorism and weapons of mass destruction. So this lecture will be a sneak peek into what I'm going to be talking about in my biodefense strategy class this fall. And so I'm going to talk for about 30 minutes, and then we'll open up for Q&A, and we'll try and answer what questions that you all have. So the scope and the severity of the COVID-19 pandemic and the inability of states like the US and others to effectively respond to this natural disease outbreak has led to a number of commentators raising concerns about ability to handle a deliberate biological attack. And this quote here from John Bolton is just one of many such comments that highlights our both vulnerability to biological attacks and the potential that this pandemic will inspire either states or non-state actors to acquire and use these weapons for their own purposes. And this is a very common reaction, but I think it misses the mark, because there are some aspects of this pandemic that do create additional incentives for states or groups to seek out these weapons. At the same time, there are parts of this pandemic that provide disincentives for doing so. And so the purpose of the talk today is to lay out a framework and some of the key factors that would help us better understand what is the overall risk that this pandemic will inspire future threats from both states and non-state actors in the biosecurity space. So first, I'm going to talk about the impact of the pandemic on our assessment of the bioterrorism risk landscape, and then look at why states want biological weapons and how the pandemic might be influencing their calculations and their considerations regarding this weapon. Before I get started, I want to lay out two caveats to my talk. The first is that the SARS-CoV-2 virus that is responsible for the COVID-19 pandemic, we do not have any evidence that it was developed as a biological weapon by China or anyone else. This is a naturally occurring coronavirus. However, the origins of this outbreak do remain murky. The most likely explanation is that this was the result of a natural spillover event from animals to humans somewhere in China that was then magnified in Wuhan. And we have precedent for that, since there were novel coronavirus spillover events that led to the SARS outbreak in 2002 and to the MERS outbreak in Saudi Arabia and the Middle East in 2012. At the same time, there are concerns that one of the laboratories in Wuhan that is known to have worked with coronaviruses could be responsible for starting the outbreak. However, there's only circumstantial evidence supporting that hypothesis. However, there's a lot of misinformation and disinformation out there that does seem to make that possibility seem higher than I think it really is. And we'll get to that a little bit at the very end of the talk. So when we think about bioterrorism, I like to use this framework to break down the components of what are the factors that lead to a risk assessment. And really there are three primary factors. The first is threat, which is a combination of the intent of a group to develop and use biological weapons, as well as the capability for doing so. Then there's the vulnerability, which is the probability that an attack would succeed once it's launched. And finally, it's the consequences. What is the scope and severity of the damages caused by an attack, minus whatever countermeasures are available that can mitigate the damage caused by such an attack. And a good risk assessment covers all three of these components: the threat, the vulnerability, and the consequence. Unfortunately, we see very often that people talk about one or two of these elements. They do not provide a comprehensive risk assessment, and therefore sometimes their conclusions are wrong or misleading because of that. But before we get to COVID-19, we have to go back to 1995 and the origins of the debate on bioterrorism. And this is because there were three events that really put this issue on the agenda. First, in March of 1995, the Japanese called Shinrikyo used the nerve gas sarin in the Tokyo subway system, which was the first major use of a weapon of mass destruction by a terrorist group that was known of at the time. A month later, Timothy McVeigh, a domestic far-right extremist, used a truck bomb to destroy the federal building in Oklahoma City, killing 168 people, which was the worst domestic terrorist attack in the US up until that point. And then a month after that, Larry Wayne Harris, a white supremacist in Ohio, was arrested for ordering the bacteria that causes plague through the mail. And even though all three of these events were unrelated, because they happened in such close proximity to one another, and they all revolved around terrorism and some kind of weapon of mass destruction, it created this very strong concern that we're entering a new phase of terrorism where these groups would be able to acquire and use weapons of mass destruction, such as biological weapons, to use against targets. And this is a debate that we've been going on for 25 years now. At the risk of oversimplifying things, that debate can be broken down into two groups or two schools of thought, the optimists and the pessimists. I'm going to provide their kind of assumptions and then their analyses as a prelude to then talking about the effects of COVID-19 on this assessment. Optimists see bioterrorism as being very rare and for good reason. Most terrorist groups, according to them, simply aren't interested in developing biological weapons, and if they were, they wouldn't be able to do so. And the primary reason for this is that most terrorist groups are very conservative in their approach. They prefer guns and bombs for causing death and destruction because these things work and they're easy to use, whereas biological weapons pose greater risks to the group and to the members trying to deploy them, much riskier, much more likely that they will fail, and therefore there's a big opportunity cost that terrorist group would have to invest in this kind of capability, even if it might fail to actually cause any casualties. And actually, that's what we saw in the case of Shinrikyo, where they had a biological weapons program alongside their chemical one, but the biological program was a complete failure, and they never caused any casualties with that weapon. In addition, optimists argue that terrorist groups are interested in calibrating the level of violence depending on what their objectives are. In the word of the terrorism expert, Brian Jenkins, terrorists want a lot of people watching, not a lot of people dead. And so for most groups, being able to cause mass casualties, mass death with biological weapons wouldn't be that appealing. They would risk alienating their constituents, both domestic and international, and violating the norm and the taboo against using disease and poison as a weapon might lead them to lose political support that they want to achieve their overall political objectives. Optimists also argue that even if a group wanted to use biological weapons, it'd be really hard for them to acquire and use this capability to cause mass casualties. And fundamentally, the reason why this is that biological weapons are not simple things that you can just make in your kitchen sink. They require a long-term R&D effort by a team of experts who have multiple disciplines and expertise, and most importantly, tacit knowledge, which is knowledge that is not easily acquired. You can't just read a book. You have to earn it through working, working in a lab or being mentored by an expert. And this tacit knowledge is much harder to acquire than the dual-use equipment that's sold, or the journal manuscripts that talk about experiments. Actually, having the skills and expertise to run the experiment is much more difficult and hard to obtain. Optimists would acknowledge that our society is inherently vulnerable to biological attacks, but that's because we live in an open society that's inherently vulnerable to lots of bad things. And for them, the overall risk posed by bioterrorism isn't sufficient to fundamentally alter the nature of a society to make it less vulnerable to these kinds of events. And even if there was a bioterrorism event, it would not be a weapon of mass destruction. Instead, it would be a weapon of mass distraction or maybe local disruption, because these would be attacks with either very small quantities of agent, very crude concoctions, very small scale targets that are hit, and so it would only have a very limited impact physically, but maybe a larger psychological impact. And based on these considerations, optimists look at the public health system as being the first line and the best line of defense against any kind of biological attack, since the ability to detect and respond to a natural disease outbreak would provide a strong protection against a deliberate biological attack. On the other side, pessimists think that bioterrorism is a matter of when, not if. And they point to a number of trends that indicate that there's increasing interest by different terrorist groups in acquiring this kind of capability. And the main one is looking at changes in the religious motivation of terrorist groups. Pessimists would acknowledge that most traditional ethno-nationalist or ideological groups, which are secular in nature, have not shown any real interest in weapons of mass destruction or biological weapons. But that's not necessarily the case with religiously motivated groups. These groups have, if they have ideologies that provide a divine inspiration for acquiring these weapons, or the framework for a cosmic battle of good versus evil, which justifies massive levels of violence to achieve their objectives, which they think are holy or sacred. This can lead groups to look at biological weapons as being something that's attractive to them. And in fact, you do see among religiously motivated groups a much higher rate of highly lethal attacks. Mass lethality attacks that kill over 100 people are much more commonly committed by groups with religious motivations than secular groups. And finally, groups that have millenarian or apocalyptic ideologies, where they think that it's their job to bring about the end of the world, or to cleanse society in anticipation of some kind of cataclysmic event, they might also be attracted to biological weapons for their ability to cause widespread death and disease in furtherance of their goals. Pessimists also point to the increasing ability of states to develop capabilities along these lines. And they point to the global diffusion of dual-use technology, information, and knowledge as enabling more and more groups and individuals to acquire the means to develop biological weapons. And also they point to advances in biotechnology that automate processes that normally would be very difficult to require a large amount of expertise. And this is a process known as de-skilling. And so this removes some of the tacit knowledge that normally be required to work in a lab. Instead, it can be replaced by equipment that automates what would otherwise be a very labor-intensive process. And pessimists also look at certain terrorist groups as being more innovative than optimists give them credit for, and groups that are innovative in terms of their tactics, their weapons, their targets, is evidence to pessimists that these kinds of groups might also be able to innovate into the biological weapons space. And if groups are constantly looking for new forms of weapons and types of attacks to conduct, then they might become interested in biological weapons, especially if they have a religious motivation or millenarian or apocalyptic ideology. And the vulnerability that pessimists see in our society and in countries around the world looks to them like invitation, an advertisement that we have an Achilles heel where you can invest a very small amount of resources in developing capability and have a disproportionate effect on a country in terms of not just the death toll, but the panic and the psychological impact that a successful bioterrorist attack would have. And these attacks, pessimists think, would be easier to pull off a more catastrophic attack that could affect an entire city and cause widespread disease, especially if a contagious agent is used. And so the combination of a high vulnerability and consequences for Pessimist really points to a high consequence risk that needs to be taken seriously. As a result, they're more willing to invest in specialized assets that are needed for biodefense purposes, such as vaccines or detection systems that are optimized for detecting biological threats that are man-made and not naturally occurring. So how does the COVID-19 pandemic affect these calculations? So on the question of capability, pessimists would look at the massive undertaking we have now to develop new vaccines and medical countermeasures, and doing much more research on coronaviruses and how they spill over and how they spread, as accelerating this trend of the diffusion of dual-use technology and knowledge and materials and information that could be misused. So even though the work that's being done now to respond to the pandemic is being motivated by public health and scientific concerns, right, it will generate knowledge that could be misused down the line. So this is a major concern for the pessimists. On the other hand, the optimists look at what's happened with the SARS-CoV-2 virus, and they say that there's no way any terrorist group would ever be able to replicate these results. Even with all of the advances we have in our knowledge now about how coronaviruses work and how we can manipulate them, even the most sophisticated scientists in the world, right, cannot could not design what SARS-CoV-2 did. Instead, this is a result of natural evolution, and I hate this phrase, but people say that Mother Nature is the best bioterrorist, right? The power of evolution and selective pressures for a virus that is well adapted to human populations is something that we've seen happen before with SARS and MERS. And again, it's just beyond the ability of a non-state actor to intentionally, deliberately design a pathogen of that nature. But pessimists would look at the vulnerability we've seen, that our response to this pandemic has been really problematic in many ways in the US and many countries. And the fact that there is now this highlighted vulnerability will, again, attract non-state actors to finding other ways to exploit this Achilles heel that our public health system, our healthcare system, is just not capable of dealing with an outbreak of this type. But for pessimists, when they look at our vulnerability, they look at the vulnerability of all countries around the world, and the fact that because pathogens don't carry passports, they don't discriminate based on race or religion, releasing any kind of contagious agent, akin to a novel coronavirus, right, risks infecting large numbers of people, including supporters of the group that designs the virus or releases the virus in the first place. And so this shared vulnerability would serve as the deterrent to groups, because they would not be able to protect their own members or their constituents or supporters, and therefore they would not want to run the risk of killing their own people. Pessimists would also point to the consequences we've seen. We've seen this one simple virus cause massive levels of death and illness, huge economic costs, social panic, public panic, and has really dominated media coverage like no event in the last 20, 30, 50 years. And so there might be groups that seek to replicate that level of consequence, or at least media attention, by using a biological weapon. Even if it's not as advanced or sophisticated or deadly as SARS-CoV-2, still this could provide a template or inspiration that if it can cause major consequences, then they would reap some benefits from that. The optimists would counter by saying that anything even close to being as lethal and dangerous and deadly as SARS-CoV-2 would be overkill for most terrorist groups, right? That are not interested in having a globe-spanning, cleansing, apocalyptic viral outbreak. It's just so far beyond what would help them achieve their local political objectives that it just would not be something that would be very appealing. And then again, because the capabilities required for these kinds of outbreaks and these kinds of pathogens are fairly sophisticated, even if a group aspired to develop a pathogen or use a weapon that would get anywhere close to the level of consequences that SARS-CoV-2 has done. Right, this will remain, an aspirational. This will remain aspirational. That they won't be able to actually realize and have developed an actual mass casualty causing biological weapon. For Optimist, right, one of the silver linings in all this is that this is massive amount of work that we're doing to develop new medical countermeasures, new diagnostics, new detection systems, strengthening public health systems and healthcare systems. These are all investments in public health that would also help mitigate the effects of a deliberate biological attack if there is one in the future. And so these investments in public health and these countermeasures can go a long way to mitigating the consequences of an attack. And that in itself might be a deterrent. That if in a couple of years from now, once we have rebuilt our public health and healthcare systems, non-state actors might look around and say, you know what, biological weapons are even less feasible than they used to be, because all these countries have these great syndromic surveillance systems and biosurveillance systems, and they can develop medical countermeasures very quickly. We won't be able to cause very many casualties, and so it's not worth it, given all the risks and costs involved. In contrast, the pessimists, again, would look at all this research as being dual use. And yes, it is generating new medical countermeasures, but at the same time, every time we learn about how to reduce the virulence of a coronavirus, we're also learning how to increase it. Every time we look at how to develop a new antiviral, we're also learning about how to the pathogen evolve to avoid these antivirals, and therefore creating new knowledge that could be misused to make these pathogens more dangerous. And so all of this dual use knowledge, if it was misused, could create a new and improved biological weapon that we're not prepared for. So my net assessment based on these components of the risk assessment is that the level of investment that we're engaging in on public health and for biodefense outweighs the small risks created by having more dual use knowledge out there and more scientists trained in how to use these technologies. And so the ability to mitigate the effects of a biological attack, I think, are increasing faster than the ability of a terrorist group to exploit and abuse these same advances. But the most important aspect of all this is intent. And this is the most important factor in our risk assessment, but also it's the hardest to measure. And so really the question becomes, will COVID-19 inspire non-state actors to seek to use biological weapons to further their political objectives? And at this point, there are two types of groups that are most concerned, far-right extremists and jihadists. For jihadist groups, so far they've really treated the pandemic more as a propaganda opportunity, where they've looked at the response, the inadequate responses of the governments they're fighting against in the Middle East and North Africa and elsewhere, really is evidence that these are illegitimate regimes, right? Not only are the infidels or apostate, but they're just incompetent. And this is therefore a good reason for people to join their cause and seek to overthrow these governments and replace them with an Islamic state of some sort. There are some groups that have talked about recruiting the coronavirus as an ally or as a soldier in their struggles, but this is, again, mostly kind of propaganda value here. However, I do remain worried about the Islamic State and its potential to capitalize on the coronavirus in a more direct way, or other biological weapons in a more direct way, because they do have a history of being very innovative in their tactics and techniques. They did experiment extensively with chemical weapons when they had sanctuary in Iraq and Syria, and clearly they have a they do have an apocalyptic ideology that does create potential for causing mass casualties, and clearly they've shown a total disregard for any norms and taboos, even ones that other terrorist groups have respected at times. So among the jihadist groups, I would be most concerned with the Islamic State looking at this pandemic as any kind of inspiration. In addition, there are also far-right extremist groups that are major sources of concern, and this ranges from neo-Nazi groups to white supremacist groups to anti-government militias, and these the coronavirus pandemic, I think, resonates with these groups to a fair bit, because it fits into what's called this acceleration strategy that some of these groups have, where they seek to cause large-scale random violence as a way of sowing discord and hopefully bringing down society from the inside. And so because the pandemic is already doing that on a certain level, you have seen some of these groups embrace the pandemic as opening up new opportunities for them to accelerate collapse, and therefore then a replacement with their own, their own preferred political system. But we've also seen a couple of isolated cases of individuals or groups talking openly about using biological agents and using coronavirus for their own purposes. But when they do so, they've talked about it in very crude terms, in terms of licking doorknobs or coughing on people. So again, very much remains in the aspirational category. No real evidence of any tangible efforts to try and actually use biological weapons at this point. And this fits with a pattern we've seen with far-right groups that have been interested, fascinated with biological weapons for a long time. And a lot of them have played around with ricin, but again, no actual use of the toxin, no causing any casualties with any kind of biological agent. So lots of talk, not a lot of action so far from those groups, which is a good thing. And the one also factor that helps reduce the risk posed by these groups, even if they are inspired or aspired to engage in bioterrorism, both these types of groups, the far-right groups, jihadist groups, tend to operate in a cellular way and in small cells, which makes it harder for law enforcement and intelligence agencies to identify them. So it helps them survive. But because they're very small, they can't amass the critical mass of expertise that they would need and tacit knowledge they would need to be able to actually develop and effectively use a biological weapon capable of causing mass casualties. So at this point, what I would say is that this is a threat we need to take seriously, but not literally. When individuals or groups talk online about using biological weapons, we shouldn't expect that they actually can or will do that. Right? It's very easy to talk about these things, but at the same time, even openly talking about using biological agents is something that most groups have not done in the past, again, because there's this taboo against the use of these weapons and all sorts of risks associated with them. And so any group or any individual that does talk about using these things or does need to be dealt with very immediately because they could pose a future threat in the future. Okay, let me shift gears and be able to talk about the state side of the equation here. So there are 4 main models to explain why states develop weapons of mass destruction, including biological weapons. So it's worth asking, how does the coronavirus pandemic affect states' calculations to develop and use biological weapons in a kind of post-pandemic era? The most common model that we've seen is the national security model, where states develop biological weapons in order to either counter a country that is stronger than them with conventional weapons, or is also armed with biological weapons or other weapons of mass destruction. So they're being driven by their national security environment and external threats to their security. And the US and Soviet development of biological weapons during the Cold War is kind of the classic model of this, where we're each afraid of the other using these weapons, so we develop them as a deterrent. In addition, some countries have developed chemical and biological weapons in order to protect the regime from internal threats, from dissidents, from insurgents, from rogue military units. And so they've been motivated by regime security, not national security. And the classic example of this is in South Africa during the apartheid era. Their Project Coast, which was developing chemical and biological weapons, was aimed at anti-apartheid activists and domestic insurgents. It was not directed at any foreign adversaries. We've also seen in history several cases of countries developing biological weapons primarily for bureaucratic reasons, that there's some small, vocal, influential group in the military or among scientists who convince a government that biological weapons are a good idea. We saw this in the case of the Soviet Union, where there were Soviet academicians who wanted to rescue Soviet biology from the legacy of Lysenkoism, and so they kind of convinced the military to invest in biology in order to develop new biological weapons, but what they really wanted was just new labs, new equipment, and the ability to do biology unfettered from the ideological restrictions that they'd faced in the past. So not a strategic motivation, but a kind of a bureaucratic motivation. And finally, in other weapon systems, we've seen prestige play a big factor, where countries develop weapons in order to demonstrate their technological sophistication or as a symbol, a status symbol. That's not been the case in the case of biological weapons, right? That countries do not openly admit they own and possess these weapons because there's that taboo against them. And there's now a biological weapons convention that makes them illegal. But that has been something we've seen in other countries. So turning to the national security model and how that might affect countries' interest in biological weapons. There are two ways that countries have looked at biological weapons to help them meet their national security objectives. The first is looking at biological weapons as a strategic weapon, a weapon capable of causing mass casualties, typically in civilian populations in urban areas, as a deterrent, as a way of threatening another country with retaliation in the event of a conflict. And we certainly have seen the death toll caused by the pandemic has reached the level that the kind of worst case scenarios about a biological attack would occur, right? And so the fact that we're now up to 140,000 deaths, is equivalent to some of the scenarios that we've seen in terms of how deadly the biological weapons the United States and Soviet Union had during the Cold War could have been. At the same time, COVID-19 has shown just how unpredictable biological weapons could be, and that countries share a vulnerability to highly transmissible and contagious diseases. So in that way, it shows one of the real drawbacks of biological weapons is this risk of blowback or boomerang effect, that just because one country uses a biological weapon doesn't mean it won't affect them, especially if you're talking about anything contagious and transmissible. That raises those risks even more. So this would be a major, I think, disincentive to developing a strategic biological weapon because of this risk of blowback in the event that they're being used. And this is clearly a much bigger concern now when we have a much more interconnected world than it was during the Cold War, where the Eastern Bloc and the Western Bloc were very much kind of separate and were divided. Another way biological weapons have been used for national security objectives is as an operational weapon to attack critical infrastructure like ports, air bases, in order to paralyze an adversary's military capabilities or go after their industrial and logistics networks. And we have seen the equivalent of that happen in this pandemic when for the first time since World War II, a U.S. Aircraft carrier was taken out of action by an enemy. Only in this case, the enemy was a microscopic virus, but it nonetheless caused a severe outbreak on board the USS Theodore Roosevelt, which had to go to Guam to dock and disembark its crew in order to isolate them and treat them and disinfect the ship. And while the Roosevelt was out of commission for about 8 weeks, for most of that time, there's no other U.S. aircraft carrier in the Western Pacific. So it did create a large power vacuum in the area. And this is clearly something that military planners would look at and be very concerned about. And so there could be the inspiration to try and develop biological weapons that replicate that effect and be able to kind of take out a carrier in the event of a crisis or a conflict. But even here, there are some other considerations, right? Most countries that the U.S. has hostile relations with already have biological weapons programs, right? So Russia, China, North Korea, Iran, we think already have these programs already underway. Other countries that are likely to be concerned about U.S. Military action, like Syria and Venezuela, right, are in no position to develop biological weapons. So I don't see a new demand for these weapons emerging from these states. And for countries that are worried about U.S. military intervention and power projection, especially by aircraft carriers, they've already been investing in kinetic means of countering that threat for many, many years. And so whether this is from Chinese anti-ship ballistic missiles or Iranian swarming boat tactics, these countries have been developing alternative ways to counter this particular threat. And it's not clear what biological weapons add to the mix, particularly if any of these countries use a biological weapon against an aircraft carrier or U.S. military asset, right? This would be crossing a red line, and this would be using a weapon of mass destruction that could very easily invite nuclear retaliation. I think it would be a major deterrent to any country actually trying to use these weapons openly in a conflict. What I'm more concerned about, as opposed to the kind of deliberate offensive BW program starting from scratch, is what I call the biosecurity dilemma, which is that countries start becoming very suspicious of other countries' biodefense programs or pandemic preparedness programs, and interpret these programs as offensive or threatening, and so they start their own program in response. And this is a classic dilemma in international relations, international security, and unfortunately, in the realm of biosecurity, right, it's in the kind of the worst possible world where it's very hard to distinguish between what is offensive and defensive, right? And in biological warfare, right, the attacker is a very strong advantage. So there's a very intense security dilemma, which I fear is going to be aggravated by several trends that are going on now. And I will address them very briefly and then open up for questions. The first is that biotechnology is just inherently what I call multi-use. It has applications and uses purely civilian in nature, needed for biodefense purposes, defensive purposes, and also for offensive applications. And just one little example of this is the bacteria Clostridium botulinum produces botulinum toxin, which is the most lethal toxin known to science. But also it's the key ingredient in the Botox that people use for cosmetic surgery. So it has a purely civilian application. At the same time, you need to use that toxin to develop antitoxins for public health reasons in order to have treatments for botulism and food poisoning. But at the same time, the same exact bacteria toxin was used by Iraq to fill up some of its biological weapons before the first Gulf War in 1991. So same bacteria, same toxin, and yet very many different applications. This is true for a lot of the technology and equipment and knowledge that's resident in the life sciences. We've also seen, especially after 2001, a growth in biosafety level 4 labs, which are the labs that are equipped to deal with the most dangerous pathogens, such as smallpox and Ebola. I expect more countries to develop these labs post-pandemic, and countries that have these labs are probably going to build more of them. This lab at the bottom is China's first BSL-4 lab in Wuhan, which obviously has been the subject of a lot of speculation about its role in the outbreak. We know China has at least 2 other BSL-4 labs planned, and maybe more now in response to this pandemic. Now, BSL-4 labs are not necessary for a biological weapons program. They're not sufficient for a biological weapons program either. But because they are kind of the symbol of the most dangerous pathogens and the most high-profile symbol of a country's investment in pathogen research, right, they are frequently seen as potentially risky, posing biosafety or biosecurity risks. And as more of these labs emerge, we're likely to see more countries raise concerns about them, in their backyards or in their neighbors or in countries that they do not have good relationships with. And this will also be a function of the types of research that scientists are going to be increasingly doing in response to the pandemic. Because, again, this pandemic was most likely a natural spillover event from animals to humans. This is something is a major problem across all zoonotic diseases. This is the major origin for most human outbreaks. And we know that there are hundreds of more coronaviruses that are circulating in bats and other animals that could be the next SARS-CoV-2, it could be the next SARS-CoV-3. And so there's going to be a lot of research being done to understand what are the risks posed by these other viruses, under what conditions are they more likely to jump from animals to humans, under what conditions will they become transmissible human to human, and all sorts of other questions that have been created by this very unexpected pandemic. And so this leads into what's called gain-of-function research, where scientists intentionally manipulate a virus in order to understand its properties and its genotype and how genotype affects phenotype as a way of understanding the biology of the organism, developing ways to look for, to do surveillance and develop vaccines and antivirals. But this kind of biology, it's the national security equivalent of red teaming, right? Where you're red teaming Mother Nature. But it is dual use, and so it does generate knowledge that could be misused. And so if this kind of research is not done transparently and openly, right, it runs the risks of countries misinterpreting or misperceiving this research as being done for offensive purposes or for illegitimate purposes. And that just becomes a major component feeder of the security dilemma, which is made even worse by the disinformation that we've seen across the board throughout this pandemic. And particularly worrisome to myself are that there are official government statements about other countries being the source of the pandemic or aggravating the pandemic, that runs the risk of other countries actually believing this and internalizing it, and therefore kind of baking in suspicion and mistrust in ways that will lead you to look at whatever another country does, even if it's for public health reasons, it will be cast as something that is somehow threatening biosafety or biosecurity. And so there's a real risk here that this will feed the security dilemma. At the very least, it's going to reduce the amount of international cooperation that we need to have to deal with the pandemic. So there's both the short-term cost and also the longer-term cost, where I think this will make the security dilemma more difficult and harder to kind of to break through. So that's what I have for my lecture today. Here's my contact info. I realize that we have a lot of people on here and a lot of questions that I will open up the Q&A function and try and answer a few of them. But if I'm unable to, I'm happy to answer questions offline if you're so interested. So let me go to the Q&A. So there's a question about how do you operationalize a risk framework of the threat times the vulnerability times the consequence numerically? And that's a very good question. And there are some people who have done that quantitatively, where they have tried to put actual kind of probabilities on the likelihood that how many groups will develop an intent to use biological weapons, how many groups will have the capability to do so, quantifying vulnerability and these other things. And this is kind of an approach that the Department of Homeland Security has taken with the bioterrorism risk assessment. The problem is a lot of these things are hard to quantify. Right? How do you quantify intent? How do you put a number on that? And so the alternative is a qualitative approach, where you're not trying to get a number that will say, yes, there's 80% chance of bioterrorism happening next year or the next 5 years. But again, looking at the conditions that make this more or less likely to occur, and trying to identify how can we intervene with different policy tools to try and reduce the risks of these conditions occurring, or how do we mitigate the consequences? There are a couple different ways to answer that question. There is no simple right way to do it, and it's a matter of understanding where the assumptions underlying these analyses and the risk assessment, and whether or not they're well founded in terms of the evidence and the analysis and the logic. Okay, so there's a question whether I'm an optimist or a pessimist, and why. And actually, there's a third category I did not talk about, which are the pragmatists, who fit kind of in between the optimists and the pessimists, because they share a lot of the pessimist concerns about the increasing number of groups, especially those that are religiously motivated, to seek out these weapons, and that the technology is more available to do so. But at the same time, they agree with the optimists that such groups are going to be very rare, and their capabilities will still be very limited. So pragmatists tend to look at the risk being posed by a very small number of discrete groups, and that they will have the ability to conduct small-scale biological attacks, right? Not large-scale outdoor aerosolization of anthrax that could affect an entire city. And so that, I think, middle ground is where I'm at. And what's key there is that in order to do those kinds of risk assessments, you really need to understand how these groups think and operate, and it requires a very close analysis. You can't just rely on big mega trends in technology or geopolitics, right? You really have to look at individual groups and their leadership and how they operate to understand to what extent they pose, how much of a threat they pose here. And again, this is part of the reason why I highlighted the Islamic State as being of concern, because I think they have a lot of those characteristics that make me worried that they would be interested in biological weapons at some point. And the pragmatists also favor public health investments that are what are called all-purpose or multi-hazard or all-hazard, where for them, right, the ideal kind of response is not something that will only deal with the very low probability threats posed by biological weapons, but will deal with a much broader array of threats. Maybe they're naturally occurring or maybe they're deliberate, but in doing investments that would be able to cover as broad a range of threats as possible. And in that context, so developing, not developing necessarily a vaccine against just one specific biothreat agent, right, but developing antivirals that work against multiple strains of a virus, developing antibiotics, broad spectrum antibiotics that can be used not just against anthrax and plague, but also can treat naturally occurring antibiotic-resistant drug pathogens and bacteria that we're seeing, right, in healthcare systems and in the public. So the pragmatists just have a slightly different way of looking at both the threat and also some of the solutions and policies in this space. So there's a question about how the Schar School is bringing this knowledge into the government dialogue on the matter, and how is the government soliciting this knowledge and perspective from the Schar School. So basically, this is kind of the interaction between academia and the government and looking at these kinds of issues. And so I have to say that this kind of event is a great way that the Schar School is trying to make this kind of knowledge and expertise known to folks in government and outside of government. We've been doing a number of panels and events since the COVID-19 pandemic occurred, looking at different aspects of how this pandemic is affecting national security, social justice, domestic violence, politics, economics, you name it. And so this is, one way that we're engaging both the public and informing policy makers. And we do a number of events, and we typically have a workshop every summer on global health security that includes a large number of folks from not just the US government, but from international governments that unfortunately we had to cancel this summer because of the pandemic, which is ironic. But the Schar School very actively engages and encourages its faculty to engage with policymakers. I do some consulting for different government agencies. I consult for DARPA on one of their genome editing programs from the perspective of the ethical, legal, and social implications of the technology. I'm probably going to be giving a version of this lecture next month at the State Department, who's expressed an interest in getting my take on how the pandemic might be affecting terrorist groups and interest down the line. So there's a very rich discussion among not just myself, but other faculty at the Schar School and government agencies about the pandemic and how this affects policy. So this is something that is key to our position as a School of Policy and Government. There's a question here about how would a biological attack on the food supply factor in the pessimist and optimist outlooks. And I think you could use the exact same framework for looking at threat and vulnerability and consequences and apply that to the potential for agroterrorism. And if you did that, you would find, again, I think you'd find a split among those who have the more pessimistic analysis of, we're highly vulnerable, the livestock is a huge part of our economy, would have a tremendous effect on exports and on GDP, would potentially threaten food security for all Americans, and that spreading an infectious disease among among livestock is relatively easy compared to doing it in an entire city, and so they would look at that threat as being quite high. On the flip side, right, optimists would say, well, there's vulnerability might be there, but we have this whole food safety network that's designed to detect disease outbreaks among plants and animals and protect public health from that. And so they would look to that as a detection system, potentially a deterrent against those types of threats. And they would also highlight the fact that terrorist groups haven't really shown any real strong interest in attacking plants and animals, right? They're much more interested in very much more visible, dramatic attacks that cause human casualties to affect their populations the most, and that there's been such a low level of interest in agroterrorism that they would expect that to continue. And again, there are evidence and arguments on both sides, and really it's up to you to sort through that evidence and arguments to determine what is you think the right level of risk that that's entailed by that particular type of threat. So there's a question here about the advisability or feasibility of protocol to the BWC for verification. That's referring to the Biological Weapons Convention, which was signed in 1972. And it's the first international treaty to ban an entire class of weapons. However, the treaty doesn't have any verification provisions in it. Right, so the IEA, so the NPT, the Nuclear Non-Proliferation Treaty, they have the IEA. They have a whole international organization that goes around and inspects nuclear power plants and makes sure that countries are not diverting their fuel or their uranium into a weapons program. Similarly, we have a Chemical Weapons Convention that bans chemical weapons. And again, they have an entire organization called the OPCW that is in charge of inspecting chemical industries and destroying chemical weapons. And they did a fantastic job of that in Syria the last couple of years. So why not do something similar for the Biological Weapons Convention? So unfortunately, the problem is that biotechnology is just very different from chemical technology, nuclear technology. And again, this goes back to the multi-use dilemma I talked about before. The number and type of facilities that have legitimate scientific, commercial, industrial applications, or even biodefense purposes that could be misused for an offensive program is huge. Because you'd only need a very small size of a facility to produce enough biological agent to cause mass casualties or be militarily significant. The scope of that inspection regime would have to be extremely wide and is probably basically untenable realistically. So instead, there have been a number of proposals to strengthen the regime as it is, to rely more on voluntary measures by countries to demonstrate that they're complying with the treaty, and doing so in ways that reduce that biosecurity dilemma that I talked about before. And so there are confidence building measures, and there's implementation support unit that's very active in Geneva supporting implementation of the that has been really the main avenue for trying to mitigate some of the concerns about non-compliance that we've seen emerge over the last couple of years. Okay, so there's a question here about the, asking me to talk more about the potential role of the lab in Wuhan as being a source of SARS-CoV-2. And so a couple things to say on that. Number one, I don't think we'll ever have a definitive answer as to who is patient zero in this outbreak, right? Who was the first person infected with SARS-CoV-2 that started this whole thing? I don't think we're ever gonna know that. And that's mostly because the epidemiology of this disease makes it really hard, right? We see what percentage of cases are asymptomatic, who never show any symptoms is very high. At the same time, a lot of those asymptomatic cases and pre-symptomatic cases can actually transmit the disease, which is not very common. Usually you have to be symptomatic yourself in order to spread the disease. In the case of SARS-CoV-2, there are people who show no signs or symptoms, and yet they are infecting other people around them unknowingly. So this kind of cryptic transmission makes it really hard to trace back and understand where people got infected in the first place. And of course, there's a 14-day incubation period associated with the virus, so you don't even know that you've been infected for up to 2 weeks. And so as a result, what I think the epidemiology is a challenge. And then also, if you look at Wuhan, I think Wuhan is the source of the part where the outbreak was detected. It wasn't necessarily where the outbreak started. And again, because of the nature of this virus and its ability to be transmitted unknowingly, this outbreak could have started anywhere in China. And Wuhan, aside from being home to a BSL-4 lab and a BSL-2 lab that do research on coronaviruses, Wuhan is also a major transportation hub. There are 4 different major railroad stations that have high-speed rail connections to the rest of China that all kind of use Wuhan as a node. And as a result, you can get to most places in China in a couple hours from Wuhan. And so it's quite plausible that this outbreak started in Guangdong province in the south, or in Yunnan province, 1,000 kilometers away, and all it would take was one infected individual who contracted the virus from from bats directly or indirectly, from a wet market, unknowingly was infected, traveled to Wuhan, and then, because this is a very large, densely populated city, triggered one or more super spreader events, right, of the kinds that we've seen in lots of places around the world. And once you have enough of those super spreader events, that reached a critical mass of cases that was finally detected by the doctors in Wuhan in late December. But I have a feeling that that outbreak was going on for weeks and weeks before that. But again, I cannot eliminate the possibility the lab was involved. But again, all of the genomic information we have so far about the strains at that lab versus the strains that we've seen in, as part of this outbreak, right? There is no direct connection. And so it's definitely an important kind of hypothesis to keep in mind, and it needs to be tested, and we need more information from the Chinese government to be able to test that hypothesis. At this point, given the epidemiology of the virus, given the precedent of past coronavirus outbreaks jumping from animals to humans, that definitely seems to be the most logical explanation for what we've seen of the pandemic so far. All right, I think I have time for one or two more questions, but there were a lot of questions here. I'm sorry I'm not going to be able to get to all of them, but the fact that you guys have all these questions is a great sign that you're interested in biodefense. And if you like this sample lecture, then I think you would enjoy the full 15-week semester that is going to be starting this fall when we resume school. So let me take one more. So there's a question here about, does the production of coronavirus vaccine by states or companies might be politicized to give them an advantage in national security? And that's a good question. And I think that is what we are seeing now today, where we see a number of countries, the US, China, Russia, and others, rushing to develop their own version of a vaccine for COVID-19, not only to help their own people, but also to use as leverage with other countries in terms of providing, favorable rates to friends and allies, maybe denying it to countries that they have, hostile relations with. And I think that this is clearly one of the major motivators driving some of the international competition developing the vaccine, which from my perspective is really counterproductive. We'd be much better off collaborating and cooperating to develop these vaccines than we would be competing against one another. And I think this fits a broader pattern that we've seen where, especially the US has kind of politicized the outbreak in ways that are very unhelpful. And what we've seen, so far, especially kind of the US-China dynamics, again, it is very unhelpful in the context of containing and controlling this outbreak. Because when great powers compete over global health and during a pandemic, the only winner is the virus. And that's just not something we should be doing. So I would have preferred to see much stronger cooperation, collaboration at international level in order to develop vaccine more quickly, in order to share resources and lessons learned. I think that would have definitely helped mitigate some of the effects of the disease we've seen so far. Unfortunately, it looks like we are out of time. But again, if you are interested in what we've been talking about today, then I encourage you to check out our program at the Schar School. We also have a website and blog called the Pandora Report, and there's a weekly newsletter you can sign up for there to get more news and analysis about biodefense and global health security. We're very active on Twitter at Pandora Report. And of course, we have a group on LinkedIn that deals with pandemics, bioterrorism, and global health security. So thank you all for listening. Stay safe, stay healthy, and hopefully I'll see some of you on campus in the future. Over to you, Travis.
Okay. Thank you, Greg. Got a little bit of echo happening here. As Professor Goblin's mentioned, we are still accepting applications for the fall. The semester starts in about a month, so if you're interested in beginning with us in the fall, it's not too late to apply, but you do need to hurry. I would say also we accept applications the spring 21 semester, which starts in January. That online application is open already. The fall 22 application should be open sometime around the middle of September. You know, Professor Goblenz has offered to serve as a resource to help field questions you have and answer questions you have about the program, and that's tremendously generous of him. Me and my team, I didn't give you my title before, so you might be saying, "Who's this Travis guy?" I'm the director of graduate admissions for the Schar School, and we're really excited that so many of you joined us today, and there were such great questions. I'm going to cheat a little bit. There's one question I want to pull from the pile and ask Greg while we still have him on the camera and microphone, because I think it has some broad application. It was a question about how this type of lecture fits in the classroom, in the context of a class. Miranda asked, for people who are in these biodefense classes, in addition to lectures, what kind of class discussions are happening? What kinds of interactive work or deliverables or papers can students in this program expect in both, the specific classes that this lecture drew from and other classes in the biodefense program?
Sure, no, that's a good question. I mean, the classes will usually be a mix of, lectures as well as discussions. So for this kind of class, for example, this lecture, I would have not just gone straight through. I would have probably stopped when I laid out the difference between optimist and pessimist, and I would have had students in the class help me fill in the assumptions of each of those schools of thought within the bioterrorism debate. I would not have just handed them the slide and said, "Here's what I think." I would have gotten what they think first, and then would have gone through, okay, here's how this matches up with the way that I see this, and use as a discussion point. Also, I like to use small group discussions a lot, so we will break up when we do classes in person. We will break groups into smaller groups to discuss a particular issue. For example, it could have thrown out to them the question of, do you think COVID-19 will make the biosecurity dilemma, better or worse? And then each group would come up with their answer and their reasons why, and then they would present, and then we would again use that as a point of discussion for the entire class. We also offer a lot of our classes online. In fact, you can take the entire master's degree online. So there's a different format for those classes, but we still bake in components that let you interact with students, interact with the professor in ways that simulate what it's like to be in a seminar, graduate seminar. And so these online classes are not these massive online courses, and what you write just goes into cyberspace and no one pays any attention to it. Right? There's weekly engagement with your fellow students, with the professor on whatever the kind of discussion questions are for that week. In terms of assignments, right, it's a mix. My assignments tend to be more kind of research papers. Other professors have more kind of briefing memos or briefing papers, or more kind of technical analyses or red teaming exercises to try and figure out how to think like a terrorist and defeat them. So there's a variety of different types of assignments you'd see in class, right? No two classes will be the same in that regard. So there'll always be a variety. And again, this is something that we've been doing online for about 6 years or so. So we have a lot of experience with this. Even though we have shifted to an all online format for this semester, this is not new to us, right? We're not going to let any pandemic get in the way of a quality education. So we are definitely prepared to, do these kinds of courses online as much as needed.
Oh, that's great. Thanks, Greg. Paul, is that admission slide ready to fly? All right. Paul Nooney is one of our academic advisors here at the Schar School, and he is also sort of the wizard behind the camera for a lot of this. Thank you, Paul. If you would like to get more information from the Schar School, more information about our programs, if you'd like to schedule an appointment with me or one of the members of the admissions team to talk about different programs at the Schar School, we actually have a number of programs in the security and policy space, and depending on your academic goals, your professional goals, a lot of folks have more than one good option, and we're happy to discuss those with you. Certainly follow us on social media there, And if you do nothing else at the end of this lecture, definitely start following the Pandora report. Greg didn't probably do it enough justice. It's truly an amazing hub of information. It's a collaborative hub of information for folks who are interested in these and other security, big policy questions, security concerns that encompass this and other related areas as well. So certainly sign up for the Pandora report. Reach out to us. Any questions at all, the email there at the bottom, shar@gmu.edu. That's the email address that we use in the graduate admissions team. If you're not sure if you have a question, you're not sure where that question should go, email it to shar@gmu.edu, and we will connect you to that person or that resource or that web page, whatever you need to get your questions answered. Because for those of you who are giving serious consideration to graduate school, it's a big decision. And we want you to do your research. And for those of you that end up in the program, there may be some of you who are starting with us this fall who got to jump on things by participating. So thanks for showing up, and we'll see you soon. Thanks again for showing up. It's tremendous to have this many folks interested in these topics, and we're happy to be, the whole SHAR community is happy to be part of the strategizing and of the solution. So as Professor Koblenz says, I wish you all good luck, good health, and feel free to reach out to us with any questions you have down the line. Thank you for joining us today.